Okay, so I'll just do version A first. So it's false, true, false, false. I guess you can figure out what's the right answer if you got it wrong, right? Anybody want to ask me a question about any of the true and false?
No.
Obviously, you can figure out the answer. You got it wrong. Okay, so when we get to multiple choice, version A, the correct answers are A, A, D, E, A, D, and E, and if you had version B, it's A, B, and E. Did I?
Oh, I did.
I'll make that change. A, D, E, and it's version B, A, B, E. And then the Earth's gravitational field was fairly easy to draw. There was the odd one or two people who forgot to put arrowheads, which fortunately is required. Those of you that didn't do that, please do that. Okay, then the next question. Now, if you've got version A, it says a force of 10.6 newtons, and my answer key is a big mess. So, can someone tell me, version A says a force of 10.6 newtons is applied to a mass of object 1.4 kilograms. Tell me which version A, what question that is in B? 13? Yeah? And is it the same numbers, Kat, or did I put different numbers? Okay, so slightly different numbers, right? Okay. So what I suggest you do, if you have version B, just if you want the correct solution, just cross out the numbers in your question and change them to mine. How is that complicated, Terry? Okay? 13. B is 13. Okay? So, oh yes, you have the weird one. Yes, you do. Yes, you do have the weird one. Yeah, yours isn't weird. That's the reason to do it, right? Okay, so here's the question. We have a force of 10.6 newtons, so that's the applied force of 10.6 newtons. Version B is 10.9? Applied to an object of mass 1.4. Version B, it's? What's the mass in version B? Okay. And it accelerates at 1.6. Determine the force of friction that is acting and the coefficient of kinetic friction above. So I'm going to draw a picture. Okay, this is a horizontal force being applied. So we find the net force to be, F net is equal to ma, 1.4 times our acceleration of 1.6, and we get 2.24 is our net force. And obviously, if you have version B, you're going to have slightly different numbers. Okay, but we know the applied force. This is the applied force. There's still a few people that are not wanting to write formulas. Unfortunately, it's just going to get harder and harder for you. The net force is 2.24. The applied force is given to be 10.6 plus FF, and then you solve that for FF. And you guys have to be able to solve these now without even thinking. I mean, you have to be able to think to do the arithmetic, but you have to know what to do. Minus 8.36 is our friction force. All right? It's really negative. Yeah? Then you gotta find the weight force. 1.4 times minus 9.8 gives you 13.72, which I guess technically is negative. And then your mu value is friction over normal. 8.36 over 13.72. This number divided by that number. And you get a mu value of 0.61. 1, 2, 3, 4. B doesn't have it? No, that's not true. A truck is pulling with 2950 newtons on a 590 kilogram trailer. It's number 11 too? Oh, so 1111. Slightly different numbers, yeah. So like I said, all you do is just cross out the numbers on B, right? And then write the answer down. That works. Perfect. Otherwise, I got to spend twice as long doing the question for your numbers, right? It's the same process, just different numbers. I could, except I seem to have somehow lost my answer key to B. I haven't.
When did you get those glasses?
These particular pair? About 5 or 6 years ago.
Never actually noticed.
I don't usually wear them. I got some contact issues, so my eye was bugging me last night. So I don't know where my answer key is, Karen. I apologize. Okay, so I'll go slow here. So we've got to chuck the 2950 newtons. So our applied force is 2950. So just cross out your applied force and change it to 2950. I have a mass of 590 kilograms. So cross yours out. And the mu value, the coefficient of friction is 0.2. Now I had lots of people think that this was the FF. Lots of people. And that is wrong. Coefficient of friction is the mu. So you are to determine the frictional force acting. Okay? Okay, so first step, FW is equal to mg. I'm going to take that mass, 590, and I'm going to multiply by minus 9.8, and I get 5782. Technically negative. Which makes the normal force 5782. Positive. Okay? And now to get the frictional force acting, we're going to go to mu equals FF over Fn. We're going to solve for, no, we know mu. Our value of mu is 0.2. And you put that 5782 under there, and you multiply 1156.4 newtons. Okay, so that's part A. And in part B, determine the trailer's acceleration, right? So you've got this applied force, you've got this friction force, so the net force is the applied force plus the friction force. How much was applied? There's 2950. Friction force is, that's negative. Now it doesn't come out as negative, but you have to know to make it negative, right? So I'm going to put plus negative 1156.4, and you get an overall net force of 1793.6 newtons. I don't know. Then you go F net is equal to MA. Take that 1793.6, 590A, divide by 590. You get 3.04 meters per second squared. Oh yeah, that's coincidence. I certainly did not. Okay, here's number 12. Number 12 says, how much force would be required to start a 4.1 kilogram object sliding along a horizontal surface? Okay, so how much force would be required to start a something kilogram object sliding along a horizontal surface? You should be able to use the analysis sheet as well to help you. So we got a mass of 4.1, and the coefficient of starting friction is 0.18. The mu value, 0.18, not FF, mu. What number is this if you've got B? Did someone find it? It's what? It's number 10? Thank you. Okay, so we're looking for how much force would be required. You're looking for the applied force. You know the mass. You know the mu. With the mass, you can find FW. M times G. 4.1 times minus 9.8. 40.18. Grady, we're just... Okay, so we got our wave force there now, and it all asks us how much force would be required to start. So you're looking for FA. Now, because the FBD looks like this, right? The FA is equal to the FF, or really, I guess the question is, how much force do you need to apply to, overcome FF, right? So we're going to solve for this value here and then say, well, we need more than that. Mu equals FF over Fn, 0.18. We're going to solve for that, 40.18. We're going to multiply 7.23 newtons is our FF. Therefore, the applied force has to be greater than 7.23 newtons. Okay, let's go to question number 13. Now, 13 was one that caused a considerable amount of difficulty for lots of people. 13 is the one where you got the moon, surface of the moon of Jupiter. So help me out here. Which one is it for B? A 1.6 kilogram object dropped from 6 meters above the surface of a moon of Jupiter. 12? Okay, so 13 and 12. So we've got a 1.6 kilogram object. The mass is 1.6. It's dropped from 6 meters above. The displacement or the distance is 6 meters. Above the surface of a moon of Jupiter. Some unnamed moon of Jupiter reaches the ground 2.66 seconds later. Annika, you getting some of this down? Yeah? What is the acceleration? So we are solving for A, and then we'll deal with B in a second here. So now there's a few people that were pretty liberal with making up formulas here. Formulas that do not exist. You can't do that. Okay? So the only two things that I know, well, I have M. Some people go FW equals mg, but we don't know the value of g. It's not on Earth. Lots of people use 9.8. It's not on Earth. You can't do that. All you've got is d and t, so you can get the average velocity, which is 2.26 meters per second. But again, that is the average. And if you have this on your paper, then it's because you don't know that average and change of velocity are not the same. They are not the same. Never have been. I've never shown you that. They are different. It's like triangle means change. This is average. Right? If I did this, if you got a 75 on the first test and then you got a 70, and I put as a final mark -5, you'd be pretty upset. What did I just give you for a mark? Your change in mark. You'd come in, I'd get parents calling, I'd be hauled down to the board office. That's what you're doing. What is the average? 72.5. There is a difference. They are not the same. So please, please, please get that straightened out before the exam. That is huge, you guys. Okay, so now you've got the average. Now you go V bar equals VI plus VF over 2, and you plug that in. And because this object is dropped, that makes the initial velocity 0 plus VF all over 2. So you get final velocity of 4.51. And now you're going to go delta V over, oh, but we don't have delta V yet, do we? So you get out your eraser and you erase that. Wow. Right? You got to do this part. Now, most of you can see that it's just going to be 4.51, right? I don't know the legal status of the moon. I don't know. Let's try to focus on this column. You have a lot of good questions. They're all usually not completely unrelated, but off on a tangent. Yeah, I know. That's what I'm saying. But I'm not going to be testing you on that. That's not something you need to know. I understand, Colin. Can we leave that for another time? So I can get this done. Okay, so my delta V is 4.51 and the time is 2.66. So your acceleration is 1.70 meters per second squared. So this moon is considerably smaller than Earth. Okay? 1, 2, 3 marks. Now, in part B says, what is the value of the force of gravity exerted by the moon on the object? By this moon in this question. Some people used 1.6 because they heard me say that once. That's Earth's moon. We're talking about Jupiter's moon here. What is the value of the force of gravity? I'm looking for the, which is the weight force. You do. It's 1.7. We just figured it out. I am sure. That's my answer right there. So I'm going to take my mass that I know to be 1.6, and I'm going to multiply by what's 1.70, and I get 2.71 newtons. There was a lot of people that didn't get that one. If you've got B, it's what? 15? Okay, thank you.
That made me mad.
I know.
Grady, do you have A or B? A? Okay, good. Do you have A or B there?
That's the one I saw.
Brant, you get A or B? A? Okay, good. Two Boy Scouts are in the woods and wanted to determine how high a certain tree is. The one Boy Scout practices until he can throw a small rock the same height as the tree. The other one times the total trip up and down to be 6.5 seconds. Calculate the height of the tree. The total trip. Total to be 6.5. Colin, can you please put the device away? Which means that the time up is 3.25. You have to divide the time there. I've told you this. The time up is equal to the time down.
Is it?
Yes, it is.
I took so long because there's no like.
You got to do it first. Then A equals delta V over delta T. Change in velocity, 31.85. That's how much the velocity changes. Right? So, what is the final velocity at the peak? It's 0, isn't it? Right? Thank you, Colin. You got to understand, I'm in the middle of something here. Okay? You should be following along with me, not thinking about other questions to ask me.
No, and that's to do with the question about Jupiter.
I understand. Stay with me. 31.85, yeah. Okay, so delta V is Vf minus Vi. This change in velocity, Vf is 0, which makes my initial velocity 31.85. No big surprise. I guess this is negative here, isn't it? Okay, now I find average. These Boy Scouts are pretty smart. The initial is 31.85, and the final velocity at the peak is 0, and we divide by 2, and we get 15.925 is our average. Remember, average is in the middle, right? For a year or two, I think, yeah.
Is that you?
Huh? No, this isn't me, no.
Oh, I thought you were gonna That's one way to
15.925 is equal to the displacement over the... Now that time is 3.25, and you get 51.76 meters. That's a tall tree. That's a giant tree.
Someone threw it all.
51 meters? That's a big tree.
Our tree was.
Some of you had a 100-meter tree. That's enormous, you guys. That's like rainforest size. 100 meters? Like, think about the length of the football field. That's how tall the tree is. You have to divide by 2 here. Some people did everything and then tried to divide by 2 at the end, and that's when you get the 100, I think. You can't do that. Number 15 is the man in the elevator, which compares to number what? 14? Man in the elevator. Okay, this one caused lots of grief too. I showed you these. It's straightforward. The apparent weight force, FWA, I think is what we were using, right?
Yeah. Yep.
Is equal to the weight force plus mass times acceleration. 71 times 9.8. And he's reaching the end of his ride to the bottom of the building. So he's weighing more at the bottom, right? Weighing more. Oops, put a double bracket there. 837.8 newtons. That's how much he weighs, but it says, what is his weight as measured by the scale in kilograms? So then you got to take that 837.8 and divide by 9.8. 85.5 kilograms. And I know that I did ones like that.
Oh, I've done it. I figured out what he weighed in pounds.
All right, number 16 is exactly the same as Kyle flying the helicopter. Virtually identical, with the exception that it is not Kyle, it is not a helicopter, it is a man in a balloon dropping his wallet. Same exact idea. Exactly. What number is it on B? 17? It's the last one? Okay. Do you think there'll be a question like this on the exam? 100% guarantee. It will not be a guy named Kyle. It will not be a man in a balloon. It will be exactly the same question.
It'll be a guy.
No, it'll be the same setup. Exactly the same. No, no. Full page. It's got to be accurate, though. Do it right. Okay, a man is on a hot air balloon that is slowly rising at a constant 4.2. He drops his wallet over the edge of the basket. After 7.4 seconds, what is the wallet's velocity? So what do we know? The initial velocity is 4.2 because the whole thing is rising at the start. And the time that the wallet falls is 7.4 seconds. And you also know the acceleration is minus 9.8. And so the first step in the sample question was this. Minus 9.8, you're going to take delta P, and you're going to multiply by your time, multiply 72.52 is the change in velocity. Now, overwhelmingly, the number one mistake was to say that that was equal to the VF. I've told you over and over again that was only true when the initial is 0. It's not true in this case. It's like a law that has an exception. A scientific law that is true only under certain conditions. Delta V is equal to VF minus VI. So minus 72.52. Solve for VF, but the VI is minus 4.2. Why minus 4.2? Because it's subtract, and the VI is plus 4.2. And you've got to be able to solve these. That goes to the other side, becomes plus, and so your VF is minus 68.32. That's step A. Step B, how far has the wallet fallen? You need to find the displacement. The only formula that has displacement in it is the one with V bar in it. So you have to find V bar, just like I showed you in the sample questions. The initial velocity is 4.2. The final is minus 68.32, all over 2, giving us an average of minus 32.06. That's the average velocity. $68, thank you. That number's right though, right? Yeah. V bar is D over T, so minus 32.06, solving for D. Our time, 7.4 seconds. So the wallet falls 237.2 meters. Part C. How far below the balloon is the wallet? Well, it fell 237.2 meters, but how far does the balloon go? Up. V bar equals D over T. The balloon is traveling at a constant 4.2 for 7.4 seconds, and so the balloon rises 31.08 meters. Plus how far the wallet fell. So the total displacement, total distance, dt, 237.2 plus 31.08, 268.28 meters. The last one, number 17. I think it's number 16 on version B, am I right? Okay. Here's another guarantee going to be on the test, on the exam, you guys. Yeah. It's a 22 kilogram mass. Pulled by 150 Newton force. So my applied force is 150 newtons, and the angle is 27 degrees. And the coefficient of friction is 0.18. What is the net acceleration of the block? 1, 2, 3, 4, 5, 6, 7 steps. Many of you got this part. You went FAX is equal to FA cos theta. Lots of you did this right. 150 times the cosine of 27, 133.7 newtons. That is that applied force, FAX. But remember, there's also an FAY. Part of that 150 actually lifts it up. And you have to find that value, FAY. It's, remember, 150 sine 27. It's opposite. 68.1. Many of you got that step too. Here's the step that lots of people messed up on. Lots of people said the normal force is equal to the weight force. That is not true here. How come? Because you've got this FAY in there, right? And I wrote Fn is not equal to Fw when FAY is greater than 0. It's only true when they are the only two forces up and down, but you've got this other one, okay? So you have to find the weight force first, mass times gravity, 22 times minus 9.8, which is minus 215.6 newtons, but that is not the normal force. And here's how I showed you how to find that normal force. Is there any acceleration vertically up and down? Is this thing accelerating, changing your velocity up and down? No. The net y force is equal to 0. What do you got in your hands, Colin? Oh, just holding it. Interesting. The net y force is made up of the weight force plus the normal force plus the FAY. Those are the three forces that act vertically, up and down. And so now leave our 0 in there. Whoa. That. Our FW is this value here, and here's where these negatives are important. So 215.6 is negative. We're solving for the normal force, and that FAY is up, is plus 68.1. Leave the normal force on this side. Take the others to the other side, and you become 215.6 minus 68.1. In other words, the normal force is 147.5. Okay, the normal force is reduced because of the y component. FAY. Yeah. There is a certain skill to planning out your solutions, and much of it comes from experience. You kind of know what's going to happen. You got the plan in your head, right? So now, mu equals FF over Fn. 0.18 is equal to friction force over normal force, 147.5. You're going to multiply, and you get 26.55. That is the friction force. Still got 2 more steps. Just holding it, Colin? Fine. Maybe you'd be using it to write the answers down. Oh. The net x, right, left and right, is the FAX plus the FF, which is that way back to the top, that FAX. 133.7 minus this 26.55. So you get a net force of 107.15, and then you can find the acceleration. Yes, it's long, isn't it? which is why I began encouraging you to show your work back at the start of the year. Because there's no way you're going to be able to do this without showing your work. Or writing formula, or any of those things. So, I stayed after school yesterday.
And did this.
No, I stayed after school yesterday and I made a list of all the questions from all the tests so that I can work towards a final exam. Because we're going
That
to
was on the board, I knew I should.
Can you give us a final review?
Yeah.
Are you sure I said in that course outline that I'm not doing a final?
No, you didn't.
Yeah, it was.
I'm sure it says.
You did, but it was worth a shot, right?
Yeah, but I lost that.
If I had a Kleenex, I'd bring it over to you, right? So here's how the exam works. You guys are examining on Tuesday, right? That's your day? Okay. There's a good chance that.
No, we're on Wednesday.
Oh, you guys are Wednesday? Okay. There's a good chance that because the exam is your redo for the test, right? Like, so I'm going to make sure. I've told you that those last two questions are going to be on the exam, right?
Yep.
Okay. So if you screw those up, they'll be on the exam.
And if you get it right,
If you get them right, then I go back to your test
you give us 100.
and I give you the mark there. Yeah.
Hallelujah.
No chat, no need for extra studying, no need for extra tests for me, no need to come in at lunch, all that stuff. The deal is, you gotta come in on the Thursday of exam week and compare. You gotta come in on the Thursday, you say, can I see my exam? I show you your exam, and you get out your test, and you go, okay, yeah, this one, yeah, okay, yeah, oh, yeah, and then I'll give you, yeah, Thursday.
Wait, if you get it right, you cross it off?
No, if you get it right in the exam, then I change your mark on your test.
Oh, you got exam Wednesday. Hours Wednesday.
Your exam is Wednesday?
Yeah.
So that means that I'm really gonna have to work hard to get all 47 exams marked Wednesday night.
We'll just do ours.
Well, I will, because I'll be marking in the afternoon.
Yeah.
Now, for me to do that, it means that I have to sort of cover almost everything, right? So the exam is going to be long. I'm going to recommend that we do the multiple choice and the short answer in class on Monday.
I think that's cool.
This next
No,
one.
no,
The exam.
Monday of exam week.
I think that's a good idea.
That is very good.
Thank you. Okay,
But that
so
also means we have to have all this stuff for
you got it, yeah. Which you would probably be anyways, right? So it'll just be multiple choice, it'll just be short answer on the Monday.
Wait.
That gives me a chance to mark them. You get a cheat sheet, you get a full page single side.
It says we'll be given some single side.
Say again?
We'll be given a full list of them.
Yeah.
You can hold that. This is all there.
You like this one?
What, is this all?
That's the outcomes for the course. Now, I will be combining a few questions. Like, I could possibly take a question like that because you get acceleration, right? I could possibly take that, turn it into a kinematics question, right?
Oh, you're gonna kill us. No, leave it like that.
I'm just saying, there are a few questions that are sort of overlap that go together. So there might be, like, I'm not going to say this question goes to this and this question, like, there's going to be a question that sort of matches this one and this one, right? And I'm going to keep track of that.
Are you gonna keep it in order?
Ish.
Soon-ish.
Well, it'll be like, as I make it, I'll be going through the units, right?
Okay.
So, but I'm not going to, like if something doesn't fit on a page, I might kind of do a little wiggle. So, ish. Okay, but if you want to compare, you got to come in on Thursday.
So if we don't,
You don't, you don't. I'm not going through 47 exams comparing them against tests. That's not fair to me. For me. I don't have them, you have them now, exactly. Okay? Yeah. So you should be looking at tests. You should find problems that you really bombed and make sure you don't bomb them.
That's it.
Right? And then guaranteed mark goes up, right?
Mr. Bennett.
I apologize. I lied. Pants are on fire.